Bueno, muy buenas noches. Estamos dando un tiempito para ver si más gente se puede conectar para empezar con el webinar. Muchas gracias por conectarse hoy. Vamos a dar unos minutitos más y arrancamos con el webinar. Well, I think perhaps we begin.
Okay, that sounds good.
Very well. So, muy buenas noches de nuevo a todos. Como saben, hoy tenemos el webinar con el tema de probióticos y disbiosis intestinal, dentro de otros, y como lanzamiento de la línea de salud digestiva. Tenemos el gran honor de contar con el doctor Dan Kalish, que es un líder de medicina funcional de Estados Unidos, y pues el agradecimiento a Designs for Health, que es quien permite que este tipo de actividades educativas se puedan dar. Así es que ahora vamos a movernos al inglés. So it's an honor to have you, Dr. Kalish. Thank you so much. Dr. Kalish is the founder of the Dane Kalish Institute. He has trained more than 5,000 practitioners in how to give current information in building a functional medical practice. He teaches clinical applications and patient communication techniques. He has published research with Mayo Clinic. He's the author of 3 books and is a notable speaker in all of integrative medicine conference. So welcome and thank you so much for being here tonight with us.
Yes, thank you for putting this on. I really appreciate it quite a bit.
And let's get started then.
All right, so we're going to talk about dysbiosis and I guess gut health in general. And in the world of functional medicine, gut health takes the center place as one of the, if not the most important variable for patients. And we had these examples just this week in my different classes that I teach. I teach this 1-year mentorship program, and one of the doctors in the class tested herself. It was a really interesting case. And she's been struggling with fertility. I think she's in her late 30s. Been struggling with fertility, no digestive symptoms at all. And she just did the digestive test because she's in our class and she wanted to do the test, to see what it was like. And it turned out that she had a parasitic infection called Entamoeba histolytica that was interfering with her hormone balance. Wow. And absolutely no digestive symptoms at all. So the chief symptom of a gut problem could be infertility because the gut inflammation triggers a cascade of hormone production, cortisol levels shoot up, progesterone and estrogen don't do very well, and the female reproductive cycle gets interfered with from the chronic inflammation. And so that's one of the central points, I think one of the hardest points for new doctors to functional medicine to learn, and it takes maybe like literally 5 or 6 years to learn this, that gut testing really needs to be done in every patient, whether they have gut symptoms or not. And that is counterintuitive. Like if I went to see my regular doctor and I had hurt my knee, and my knee, maybe it was broken, maybe it wasn't, I don't know, but it's really painful, I can't walk. And then she suggested that we take an MRI of my shoulder. I would think that she was crazy, right? Because, like, why don't you just take an image of where the problem is? I want to see if the cartilage is torn in my knee or not. And so it's very counterintuitive to do a test when there's no presence of symptoms in that area, but it's an important thing. And we see gut problems, or I should say, let's put it in the positive. I see gut treatments resolving neurological issues frequently, depression, anxiety, hormone problems, as I just mentioned. Of course, chronic fatigue is often tied back to gut problems. And then there's the obvious things like, digestive symptoms themselves, patients that have ulcerative colitis or Crohn's disease or just IBS or IBD or, upper GI problems. I mean, those are kind of obviously worth screening. And we do see with the majority of people with, for example, reflux, will have infections like Giardia or H. pylori or a yeast overgrowth. We see that all the time. And then we also have, this was a funny week in my classes because we have a second doctor in the same class who tested herself. And she has a long history of chronic illness, like 25 years where she's been sick. And you look at the list of her symptoms, it's amazing she can still practice. But, joint pain, fatigue, anxiety, depression. She's on a half a dozen different medications, but just kind of gradually getting worse. And a lot of digestive symptoms also for decades. Exact same class. This has never happened before. She also had entamoeba histolytica, right? So we have this one class with two doctors as the patients in the class. It's kind of fun because we get to talk to them about, hey, what is it like to have this digestive tract infection and not know about it for decades? So I'm a very strong advocate for lab testing because you just never know. If they have a digestive problem, you should rule in or rule out dysbiosis, parasitic infection, bacterial infection, all these different kind of gut bugs. And if they don't have a digestive tract problem, you should still look at it too. Okay, so that's one of the chief concepts. Here's a slide on me. I've been in practice forever. I've been teaching forever. Oh, and then we have a lot of boot camps, these short form classes that we do. If you guys want to really get into lab testing and lab analytics, I know the lab testing is now available in Costa Rica because I spoke with several of the labs about this. You guys can actually get all these tests now. And we also managed to make it so the price is not as crazy as it used to be, which is great. And so you're welcome to join us in any of these boot camps. You can look at our website. The one that's starting soon is this one on amino acids. I guess it started last week, but you can still join that one. And if you look at the website, you'll see there's maybe a dozen other courses that we do. And every month there's a couple of short classes if you're just interested in exposing yourself more to these issues. And we do have also every couple of months we have a boot camp on GI health if you want to get more into the GI work based on what you learn about tonight. Okay, so then we're going to start with protocols. So when if you guys are used to reading scientific papers or academic papers, they're always built in the same way, where they introduce a subject, it's a little abstract, and then they build an argument, build an argument, build an argument, and at the end, they kind of tell you the punchline of what they're actually trying to prove, right? And if you read a newspaper article, it's kind of the opposite, where the very first thing you read, the headline, tells you everything you need to know. You can even just read the headline and then go and read another article, right? So what many times these classes are taught, or the classes that I took when I was a student are taught, where you get the answer at the very end. And what I found works better for clinicians is if we give you the answer in the beginning and then describe why we can use it or how we can use it. Just like a reporter in a newspaper article would say, earthquake happened in Morocco, and then okay, this is, they're not building up to that conclusion. So what doctors always want to know when they join my classes is what are the protocols? So I want to start there, and then we're going to work our way backwards and look at lab results, because all these protocols, whether you use them or not, is going to be determined based on the labs. So once you know what the protocols are and you know how to read the lab, poosh, you can put these two things together and you'll be able to do this easily, okay? So this is an oversimplification to get people started. When you get better at this, you can mix and match things and move them around. However, what I'm talking about tonight is incredibly clinically effective. You may also find yourself using these exact same protocols 10 years from now just because they work so well. Okay, so just because they're entry-level protocols doesn't mean that they're not effective. And in fact, you see a curve in the learning of doctors where in the beginning they do really basic protocols, and then like around year 5 of their training they get super complex, and then around year 30 or 40, which is where I am now, you go back to doing really simple protocols because you realize the really simple stuff works really well. And so I understand that the younger doctors want it, they want all the new products and they want to make it complicated. And when you're 5 years in practice, everything's so exciting, you want to learn all the new stuff. But then when you get kind of old like I am, you realize, wow, these basic programs are really what people need. And the human body hasn't changed in the last couple of decades, right? It's just the basics done well that work. So this is the most fundamental thing you could imagine is a probiotic. And we've had, I mean, you can't even, it's really hard to explain the effects of this stuff. Just as a simple case, we had a brand new doctor in my mentorship class. This happened about 2 or 3 months ago. And all she did was take this child that had autistic spectrum disorder type problems. That's like a 10 or 11-year-old boy. All she did was put the kid on a probiotic while they were waiting for the lab test results to come back. She did do the test, but she was like, the mom wanted something to do while the test results were out and waiting to come back. And all she did was put this kid on a probiotic. She comes into our class the next week and says, I can't believe this, but for the first time in this kid's life, he's actually able to speak in full sentences just from a probiotic, okay? So we don't want to underestimate the effects of this stuff. You never know what neurological problem or immune problem or gut problem or emotional problem is tied into the gut until you actually start to treat it. So anyways, very effective using probiotics, ProBiomed 50. I've been using this one since it first came out, a couple of capsules a day. Some doctors prefer to give it with meals, some without. You really can do it either way. People argue about which one's better. I usually just do it with meals, but you can do it without meals as well. Okay, and then protocol number 2. Oh, by the way, and these are in stages. So stage 1, we're going to talk about in a minute. Stage 1 means there's a microbiome problem. So if you look at the lab and you see there's a stage 1 present, you use this product. Okay, it's that simple. Stage 2 means there's a GI organ problem present on the lab, and I'll show you how to identify stage 2 on the labs in a minute. Also, this product's been around forever. I've been using this for 20 or 30 years, GI Revive. It's kind of the classic powder that's used in the US for gut repair. And it's 1 or 2 scoops daily. Now, this one, it does matter. It's really going to be much more effective on an empty stomach. And you can do, if you want to really get someone's gut better fast, do 2 scoops twice a day, maybe for the first month or 2, and then back it down to maybe 2 scoops once a day, something like that. So you can do a loading dose where you give the person a little extra. And it's got all the things that you would imagine for gut health, the glutamine and all the anti-inflammatory herbs, everything that you need for gut health, gut repair. It's kind of an anti-inflammatory. That's what I would think of it as. You can also use, instead of GI Revive, you can also use just a straight glutamine powder, but the GI Revive is a little better if you have the option to get it, okay? That's for stage 2. That's when the digestive tract organs are involved. And then you have an antimicrobial for what I call stage 3. So this would be pathogens. So stage 1 is a microbiome imbalance. Stage 2 is a GI organ problem. And stage 3, there's some kind of pathogen present. And so GI microbex is a combination of a whole variety of herbs that are antimicrobial in a variety of different ways. So some of them you may have heard of, Artemisia or sweet wormwood. It's got black walnut, berberine, and collectively they have a pretty potent antimicrobial effect. So it can kill parasitic infections, yeast or bacterial overgrowth. It's not very good for H. pylori. I would not use it for H. pylori, and I would not use it for C. diff. So there's a few infections you wouldn't use it for, but probably 70% of the time you can use this one product. And you want to dose it at either 1 or 2 capsules, anywhere from 1 to 3 times a day. So the sort of entry-level dose would be 1 capsule, let's say twice a day. The highest dose you'd want to go would be around 2 capsules 3 times a day. That's kind of a lot if you need to go aggressive, okay? But you can, patients usually tolerate it pretty well if their liver's in good shape. So then in terms of what protocol you're going to use, we're going to look at these labs and lab findings and allow you to be able to categorize people as a stage 1, 2, or 3. Once you get that figured out, then you can start to think about your experience and your comfort level. Are you comfortable doing these pathogen treatments? Would you rather just start with probiotics? So depending on what stages are present, you have a variety of choices about which stage you want to treat. And the way I've structured this, if you want sort of the lowest risk of side effects stage, then just do a stage 1 treatment. The stage 3 treatments where you're killing pathogens, it's more likely the person's going to have some side effects, so you're going to have to do some problem solving. You also may want to take into account not only your experience, but what's going on with the patient and how severe their symptoms are. So you probably don't want to try the most aggressive program with the sickest patient that you have. You want to start gently on the really sick folks. And someone who's a 22-year-old who's pretty healthy and just has, a little bit of a, I don't know, reflux or something, you could get more aggressive with the treatments because they'll probably handle it quite easily. There's a factor of cost, because these supplements can add up and get expensive. And then it's also what the patient wants to do. Do they feel like they want to be fixing this immediately as quickly as they can, or do they want to, take the time to do it gradually? So you have a lot of different options depending on which way you want to go. And I think it's pretty well accepted, and I'm sure you all in your practices know this, that a large percentage of people that we work with have some kind of functional GI disorder. So we're not talking about disease processes that would put you in the hospital, but it's like heartburn and reflux and nausea and constipation and diarrhea. And the problems, honestly, that people often don't even go to their doctor for. They just live with them and they just complain about being bloated to their spouse all the time. And it's just kind of like the way it is. In fact, my wife and I were at this restaurant a couple of weeks ago. This is the funniest thing. We're at this restaurant, and it's a nice restaurant. It's not a cheap restaurant, right? We were on a vacation. It was her birthday. It was a very nice restaurant. And the waitress was trying to convince my wife to get this pasta dish, and her sales pitch was that it won't cause any bloating. I was like, okay, that's a little strange information. But obviously, if the waitress at a nice restaurant is saying this, she knows that a lot of her clients are bloating all the time. And if they eat the wrong kind of pasta, they're going to get sick. So, anyways, people live with these problems for long periods of time. And a lot of the functional medicine practices that we see do really well with, let's call it like a wellness practice or a preventive practice, and not necessarily working just with chronically ill patients, but also working with people who get bloated when they eat too much pasta, that would be benefited by a lab test. And, it's not like even really a medical issue at that point. It's more of a lifestyle problem. But functional medicine works really well for those lightweight problems also. Okay, so let's look at the 3 different stages so you can see what these are. It's pretty simple, okay? The first stage is going to be all about gut bacteria, the good gut bacteria. The good gut bacteria, and there's a nice little image here of this is a good one. This is a commensal. It's reaching its little arms into your body across the gut lining, and it's controlling your regulatory T cells. So in other words, this gut bacteria, let me say this again, because it's kind of hard to believe this actually happens. This good gut bacteria gets through the intestinal tract lining and regulates your immune system. It's not interacting with your immune system, it's directing it. So the good or commensal gut bacteria have a really strong role to play in immune function. You could look at similar diagrams for how the good gut bacteria that produce butyrate, this butyrate travels to the brain and causes brain cell growth. So gut bacteria can also turn on or off whether your brain cells are growing through the functions of butyrate, which stimulates something called brain-derived neurotrophic factor, or BDNF. The list, it affects metabolic rate. The good commensal bacteria affect just about any system you can name. It's shocking when we get into it. Even cardiovascular health, there's some of these bacteria that help regulate that. So one of the main things that we want to have as a goal is to have a patient have a good amount of the good bacteria and a good amount of the mucosal lining that protects the gut tissue itself. So here you can see on a fiber-rich diet, that little pink kind of color there is the mucosal lining, which is thick. And on a fiber-free diet, that means this junk food diet, you don't have that protection of the mucosa. You have an overgrowth of bacteria. So an overgrowth of bacteria, harmful bacteria, is what we call dysbiosis. And that's going to damage the gut lining and interfere with absorption. But it's also going to interfere with hormone production, immune function, brain function, cardiometabolic health, right? It's about a lot more than just whether your gut is functioning or not. It affects, my old teacher, Dr. Timmons, used to say that the digestive tract is the mother of the body. It feeds all the other organs, right? So it's very much in an interactive system here. And this is just, I mean, I studied this for, I don't know, like over a decade, honestly. And um, there's so many of these commensal bacteria, and it's so complicated. So this is just one bacteria, one of the good ones, D-sulfovibrio piger. It's called D. piger. And it, just that one bacteria, there's studies that show it's related to Parkinson's, heart attacks, cancer, liver disease, kidney disease, autoimmune disease, problems with your teeth, if you can believe that, metabolic syndrome, IBS, IBD, autism. I mean, there's research on these bugs now that's just coming out. It's just insane. They're You wouldn't believe it unless you get in the literature a little bit and read about it. And that's just one bug. There's hundreds of these that they're studying now. Okay. And so we want a balance of the good bacteria so that they're in control and these bad organisms cannot proliferate. So then the question is, well, how does this microbiome get messed up in the first place? And in general, it's by unhealthy lifestyle habits, which is not eating the right food. You have to have two different things in your diet every meal: fiber and polyphenols. There's a whole group of gut bacteria that can only survive if they have dietary fiber. And there's another group of gut bacteria that can only survive if you have polyphenols in your diet. If you don't have those two foods all the time, every day, then the microbiome is just going to collapse because it's not going to have the nutrients that it needs to survive. And we had this happened again in class a few weeks ago. It was a patient that someone was submitting, and the patient had a perfect microbiome on the test. And that is just so rare to see that I immediately just asked the doctor, okay, what does this person eat? And it's always the same answer: plant-based diet, maybe some meat and fish, that's fine, but heavily impacted. You have to eat a lot of plants every day to have a healthy microbiome. I can guarantee you, if you have patients that do not eat fresh fruit and vegetables and beans and some grains every day, you can skip the grains, but you have to have the beans. If you don't have those foods every day, your microbiome is not going to do well. Beans are the best source of the dietary fiber that feeds the microbiome. And I don't know, in your country, I think it's probably more routine that people eat beans every day. But in the US, when I buy beans at the store, the grocery store, people look at me like something's wrong. Like really, there's one time the woman that was, collecting the money, she looked at me like, wow, what's wrong? This guy's a little sketchy. Why is he buying all these beans? I mean, it's literally a food that Americans have just forgotten about, but it's the essential deliverer. It's the way that we deliver that fiber that these good gut bacteria need. And it's lentils, black beans, pinto beans, garbanzo beans, doesn't really matter. Any kind of legume or bean is going to be key. Okay. So again, the microbiome disruption starts from stress, poor diet, not enough sleep, those kinds of things. And then the gut lining starts to degrade, and all of a sudden things aren't working so well. And this is a nice diagram. You can see up here the plant particle and the primary plant fiber degraders. So there's a group of bacteria that live on the fiber from your beans and from your vegetables and from your apples and whatnot. And if they don't get that food, they're not going to survive. Now, where this gets very interesting is there's another group of, can you see my arrow moving around there on the screen? You can? Okay, good. Oh, sorry, hit the wrong button. There's another group of bacteria, these secondary glycan degraders. And guess what? They rely upon that first group. And then that feeds into here. You see, each of these bacterial groups is dependent on a different bacterial group to survive. So they call them guilds. I don't know what the word is in Spanish, but in English, guild, it's like a grouping, or it's a very old-fashioned word. But they're groupings of organisms that mutually support one another. And it's fascinating. And this is the good bacteria. They're living together in sort of a happy little world. Polyphenols, as you know, come from fruits and vegetables, green tea, things like that. The famous source for polyphenols would be berries, blueberries, cranberries, pomegranate. In fact, really you want to be eating some form of a berry or something that's very polyphenol rich every day. It doesn't have to be every meal, but every day. And so those polyphenols, most of them are a very large molecular structure. They're just big, and they do not cross into the bloodstream very well. They get stuck in your gut. But what happens is when they make it to your large intestine, the good bacteria in the large intestine feed on them. So when I go out and eat blueberries in the morning, polyphenols in that blueberry are not for me. They're feeding my gut bacteria. They're the fuel supply for my gut bacteria. That's why they're so good for you. Okay. It's fascinating. You're actually literally spending money to buy food to give to your gut bacteria. But then what do they give you back? Well, they make all these metabolites the gut bacteria do, which are anti-cancer, anti-diabetic, anti-inflammatory, help your brain, help your heart. All these things are benefited by you consuming polyphenols, and then the gut making these polyphenol metabolites. Now, there's a test that you can do that's called an organic acids test, and that actually measures these polyphenols that are produced by your gut bacteria. That's kind of not what the class is about tonight, but you should know this. If you ever want to run an organic acids profile, and there's two different lab companies. DSL Lab has something called an omics test, OMX, or they also have an organic acids test. And then Genova has a Nutraval or also a metabolomics. The nice thing about the metabolomics, it's a urine sample only, there's no blood sample. And then for DSL Lab, the nice thing about their organic acids, again, it's urine sample only, so you don't have to deal with the blood draw. It's much easier just to do the urine samples only. And they have all the polyphenol markers from the organic acids from DSL Lab and the metabolomics test from Genova. It's also less expensive, and shipping blood internationally is kind of complicated. So the urine samples are easier to deal with. Okay, so you can measure all this, and you can tell exactly what your patient's polyphenol levels are like. It's kind of cool. All right, so that's stage one, microbiome, polyphenols and fiber that's feeding the good bacteria. Stage two, if the microbiome is screwed up, then over time, the gut organs are going to be involved, your stomach, your pancreas, your gallbladder, your intestinal tract lining. And now you have a bigger problem. And you can test for all these things on the labs. They'll look at the functional utilization, well, the functional expression, I guess you might say, of the pancreas, of the stomach, of the gallbladder, of the large intestine. So these are not tests for disease processes. They're just tests to see if the organs are working properly or not. And if the lab shows that there's a problem with any of these organs, then you can fix them with a variety of supplements. And the one that we're talking about tonight is mostly the GI Revive, which would repair digestive tract inflammation and tissue damage to the organ itself, right? You can also use digestive enzymes if there's a problem with the pancreas. You can use gallbladder support if there's a problem with the gallbladder, etc. So then at stage three is the body's immune defenses have dropped. They're weak now. And so pathogens have a route to get in. I don't know. It's just like if you're watching a movie. I don't know what's a typical movie like the Romans, and the Romans are fighting the Gauls or something, right? It's like a war movie, and the Romans have all these soldiers lined up in the front, so no one can get in because there's all these big guys with shields and spears and stuff. But what if the front defense line for the Romans just fell down? They all ran away. Then the bad guys could come right over, right? So your pathogens, whether they're expressed or not, is going to be mostly dependent on the immune response in the gut. A good immune response in the gut, and you can handle pathogens. We see this all the time. You could pick up an infection in your gut. If your immune response is strong, you'll just kick it out. Just like if you had a million Roman soldiers in the front there, they wouldn't let anything through, right? Of course, you'll get sick if you drink a glass of water with like crypto in it, but 2 or 3 days later, diarrhea, vomiting, nausea, you just flush it out and it's gone. But what we see frequently in our practices is people who have a weakened immune defense. And so that infection that they picked up from a bad glass of water, they still have it 15 years later. And that's a big part of functional medicine these days, is assessing, testing for, assessing, and treating these long-term infections that have been going on for decades. Like the two doctors in my class that both have EHISTO, they've both been sick for over 15 years. Okay. They both have had these problems. In fact, the woman with the hormone issue, because we're saying, okay, we don't have any digestive symptoms, but when your hormone problems first started, I think she was like 15 years old or something. It was a long time ago. And so she picked up her infection probably as a teenager. And now she's in her 30s trying to get pregnant and just had no idea that she had the infection this whole time. Okay. So that happens a lot. So stage one is the microbiome is out of balance. Stage two is the organs aren't doing well. And then stage three is these infections flare up. But these infections flare up because the microbiome is weak and it allows it to happen. And the GI organs are inflamed and the immune response in the GI tract isn't working well. That's why the whole problem starts in general. Okay. And then dysbiosis specifically is a term that used to be just an integrative medicine, natural medicine term, but now it's in the regular medical literature, which is kind of interesting. That doesn't happen very often, that people in my field of natural medicine make up a name and then the regular medical community takes it over. It's kind of funny. But anyways, that's what's happened now. So it's sort of an accepted term, but it's basically saying dysbiosis is basically an overgrowth of potentially harmful bacteria. Okay. Now, once you get dysbiosis or a parasitic infection, that's going to make this whole cycle worse. It's going to disrupt the microbiome more, screw up your organs more, right? So there's a circular nature to the damage here. So if we want to kind of summarize, and we're going to look at labs in in a few minutes so you guys can see some real examples. Functional GI concerns are incredibly common. It's maybe almost half the population. It's probably 3/4 of the people that I see in my practice have some gut problems. It's pretty common. Lifestyle choices and the gut microbiome and the immune system are really the driving forces for this happening. And if you can use these 3 stages of GI dysfunction as your guide, then you can just look at, okay, this lab shows a stage 1, I'm going to do this program. On stage 2, I'm going to do this program. Stage 3, I'm going to do this. And then you'll have a starting point with every lab. You don't have to get overwhelmed by it. So again, stage 1, it's cumulative stress, poor diet, weakening the adrenal glands, causing all kinds of inflammation. Stage 2, the organs are compromised. Now you're not making as much hydrochloric acid in the stomach. You're not making as many pancreatic enzymes, not as much bile. The leaky gut starts. There's damage to the gut lining, lowering of the gut immunity. The GI Revive is designed to reverse that gut damage to the lining of the gut, that damage to the gut immunity. It's designed to reverse that, right? And then you can also use gallbladder support and pancreatic enzymes to support that as well. And then in stage 3, you've got a pathogen. Once you've got a pathogen and the immune system is weak, you kind of are stuck having to kill it. Even though there's this progression, at some point you're going to have to kill it. So you can start with any case treating stage 1 first with probiotics, get the person healthier, then start to work on their gut lining, or maybe do a stage 1 and 2 together. So you could give them the probiotics and the GI Revive for a couple of months. That'll make most people feel quite a bit better. And then when you think, oh gosh, I think this person's actually getting healthier, then go after the pathogen later. That's probably the safest strategy that we usually recommend. 1 or 2 months of building the person up with the probiotics and the GI Revive. Let's say 60 days of that. So you're really strengthening their system. And then if they have a pathogen, going after it once their immune system is upregulated. Because remember, it all comes back to, it's not the pathogen that's the problem, it's the host. And when you hear Giardia or crypto or yeast overgrowth, you're just thinking, oh my gosh, you just want to kill that. And it's like an invader. But it's not really. I mean, we're constantly exposed to these bugs. I mean, every time you go out in public and touch a doorknob, if you have ever used a restroom in a restaurant, I mean, just think how many germs are everywhere. It's disgusting, right? So we're exposed to these things all the time, all the time. It's 100% the weakening of the host's immune response and the weakening of their gut microbiome that's creating these problems. Okay. And so you want to just spend a little bit of time strengthening if you are going to go after the pathogen, and then go after the pathogen aggressively. And again, as I mentioned earlier, if you're a little nervous about pathogen killing, then you can just stick with the probiotics and GI Revive and just see if that's enough to get the person back on track. Okay, so we're going to look at labs in a minute. Stage 1, normal bacteria out of balance. Stage 2, we're going to look for organ issues. Stage 3 for pathogens. Oh, I mean, we'll look at that in a minute, but I wanted to mention one other thing because this is really important. This is how the microbiome actually works. So you eat the dietary fiber. That's not for you. Your body can't digest it. The gut bacteria break down that fiber. And what do they turn it into? They turn it into fat. I mean, just think about how strange that is. You've got these billions of bacteria, trillions of bacteria in your gut. They're just waiting there. You haven't eaten for a while. They're hungry too. You eat some fiber, some beans, or an apple. They eat the fiber themselves. And the waste product that they dump out are these short chain fatty acids. The main one is called butyrate. But butyrate regulates everything from your brain to your immune regulation. I mean, butyrate is a very important molecule. It's a byproduct to these bacteria. They don't want it. It's what they're dumping out. They want the fiber. That's their fuel supply. But those short chain fatty acids are essential for human survival. Okay. And then the bacteria that make those short chain fatty acids are also going to stimulate another group of bacteria that produce hydrogen. They make hydrogen gas. And believe it or not, there's a different group of bacteria in your gut that consume the hydrogen gas that other group make. And then when the hydrogen consumers consume the hydrogen, then it gives the room and the space for the hydrogen producers to make more hydrogen, and then the cycle goes like that. So this is the guilds, or these different groupings of these organisms. One living on fiber, one making hydrogen, one living on hydrogen. It's fascinating. And they're all kind of relying upon one another to function well. And then butyrate worth reading about. It's pretty amazing. So there's a group of bacteria that I mentioned that consume the fiber and make butyrate. And then butyrate does all these things that you can't even believe. Anti-inflammatory effect. It has an antimicrobial effect. It has an effect on the gut lining. It has an effect on your brain. It's just an incredible compound. Really, you could read about it for years. There's a lot of information out there on it. Okay, it's very, very important. And it's a fat. It's a short chain fatty acid. It has a huge role to play with mitochondrial health too. You can see that in the diagram there. Oh, and I forgot the most important thing. It's like 60% or more of the energy that the cells in the gut lining use comes from butyrate. Okay, so butyrate as a fat goes into the gut cells, and through beta oxidation, like you do with other fats, you start to turn the butyrate into energy. And the majority of the intestinal tract lining cells rely upon butyrate as a fuel source. It's like 60+% of the energy is coming from butyrate. So it's really important for your gut. And the gut brain connection I mentioned several times. And this is, again, something people devote their whole scientific careers to. It's quite an interesting field. But there are feedback loops between gut bacteria and the brain that operate in a whole variety of different ways. Okay. And it's quite fascinating. It's a whole area of study. If you ever have time to read about it, it's pretty interesting. But the bottom line with this connection is that many patients with depression, anxiety, sleep disorders, fatigue, memory problems will have an improvement when you treat their gut. And it's not a coincidence, it's a well-established scientific reality that the gut and the brain are connected. Oh, and this is a little overkill, but I just think it's interesting that your body makes hydrogen. I mean, the gut bacteria make hydrogen, and then that these other bacteria that consume it. It's crazy. This is all going on inside it's like your intestinal tract is like a fermentation tank. And there's this is a little sciencey stuff, but it's pretty interesting if you want to read about it. Not necessary for clinical practice, but it's interesting to see how this all works. So then there's different groupings of bacteria, and you can see these on the lab reports. There's some of them that I just mentioned that convert fiber to fat. And the most famous of these right now is this one called Faecalibacterium prausnitzii. That's one you should know about because that's one that's implicated in long COVID. So with a lot of the long COVID patients have low Faecalibacterium prausnitzii. It's not all long COVID patients, but it's very common finding. And so there's a lot of research now. They're trying to figure out how COVID affects the gut bacteria. And they know that it causes dysbiosis, but what about, a year after you had COVID, now what's happening with the microbiome? So a lot of people are looking at that as a potential treatment for long COVID patients because there's a certain percentage of them that have pretty bad gut problems. So again, there's these bacteria that metabolize dietary fiber, and they ebb and flow depending on what you're eating. If you don't eat dietary fiber, I had a patient once, this was like 20 years ago, and she lived only on Burger King. She was a second-rate actress in Los Angeles, like someone that you kind of recognize who she is, but you don't know her name, that kind of person. And she was in her late 20s, and she just ate Burger King like 2 or 3 times a day. She didn't eat really vegetables or fruit. It's amazing people can survive doing that. But if you have a low fiber diet, I mean, it's kind of extreme, and low polyphenol diet, these bacteria are just going to go away. They just disappear, right? The populations just dwindle. These are the hydrogen producing bacteria here. And this is just kind of interest. You don't have to memorize any of this, but just so you know that there's a sequence, that's the important part. Some consume fiber, some make hydrogen, some consume hydrogen. And the reason why these bacteria make hydrogen is because as they're running through their metabolic processes, well, if with humans, we have the same problem, right? We're making energy, but then we have oxygen present. So we can take our hydrogens, combine it with oxygen, and we end up with water in humans. But these bacteria are living in an anaerobic environment in your intestinal tract. There's no oxygen around. So they have to take the hydrogen, bind it with another hydrogen, and they end up making hydrogen gas. Whereas we, when we make energy, would make water as a byproduct. Well, CO2 and water, right? It's interesting kind of thing. So that hydrogen gas, though, is very important for your overall health, and it's important for the other bacteria that consume the hydrogen. So it's a beautiful system that these bacteria have worked out. Okay, so let's see here. Some of these are, and then there's this other thing. This is more science. This is just like a fun fact. There's this one type of bacteria that's actually, it's not a bacteria, it's an archaea. So we have non it's just a whole different kind of organism. It's like the kind of organism you see in like the deep sea hot water vents and stuff. There's actually one of these bugs that lives in your gut that's an archaea. It's called Methanobrevibacter smithii. That's just kind of like a fun little thing, and it produces methane of all things. One of the most important and famous of these good gut bacteria is called Akkermansia muciniphila, and that is one that keeps the gut lining really healthy. It's like a lawnmower, and it just goes out and it sort of trims the gut mucosal tissue. It consumes it. You can see mucinophilia, so it's mucin loving. That's the name of it. So it's eating the mucin or the mucus in the intestinal tract lining and keeping it healthy, basically. Very important. And they've done thousands of research studies on Akkermansia in relation to all kinds of different conditions, including things like obesity and diabetes and atherosclerosis. Turns out to be a very important gut bacteria. So when I'm presenting these labs to patients, I'd usually like to, have maybe 3 or 4 of them that I can talk about. When you see the lab reports, you'll see some of these companies have a dozen. Some of them have like 50 different organisms that they report on. So you don't need to learn them all, but it's good to learn like Faecalibacterium prausnitzii because of long COVID. Akkermansia is kind of famous and important. The M. smithii one is really important because it's been shown to help prevent heart disease. There's a few of these that it's worth learning. But you don't certainly have to learn them all. And then you could just take a picture of this slide. Basically, this is just like eating habits and lifestyle changes and things like that that are sort of basic that you want to do. Because just want to mention that, it's not just about the labs. You also want to do some lifestyle stuff too with people. So let's look at, I'm just going to show you, can skip over some of these slides. There's a little too much detail, I think. We want to look at the labs in the remaining time we have. So just as a quick reminder, we have these 3 protocols, stage 1 protocol, stage 2, and stage 3, right? And so let's look at now a couple of lab tests so you can see how this might be applied. And I have a few of them here I pulled up. So here's one. It's from a company called Diagnostic Solutions. It's a very popular test in the United States right now called the GI map. And on this one, you can see, we'll just go through the stages. I'm going to skip around on the test so you can see the different stages. So here is commensal bacteria. You can see it's called commensal/keystone bacteria. So this is an analysis through PCR of the good gut bacteria. And they have maybe like a dozen of them. Here's my favorite one, Akkermansia. You see that one there. Here's our Faecalibacterium prausnitzii, the long COVID one. Some of these you may have heard of. Lactobacillus is kind of famous. It's in a lot of supplements. Bifidobacterium is kind of famous. They also sell that in probiotic supplements. So this is a nice analysis of the commensal or good bacteria. And you can see on this example, there's maybe 4 of them that are low. So this person's microbiome is underperforming. So they are stage 1. So what do you want to do? Prebiotics, probiotics, polyphenols, fiber, right? With a diet would be polyphenols and fiber, increase, and then you can use the probiotics that are in that protocol. It takes 3 or 4 days of a high fiber, high polyphenol diet to see these markers move. It doesn't take that long. I've had patients where it happens, within a meal, but usually they say it takes 3 or 4 days of eating the right food. Every meal that you eat that's the right meal is going to lead to the bacteria coming back. And every meal that you eat that's not full of polyphenols and fiber is going to lead to the good bacteria dying off. It's a meal by meal thing, right? But obviously, I used to do this thing when I taught these nutrition classes where we'd get like 100 people in the room, and then I would hand out this questionnaire, and it was like a health appraisal questionnaire, sort of rated the scale, and it was like 0 to 500 or something. And then I would find the person in the room that had the best score. So basically, like the healthiest person out of these 100 people. And then I would have them stand up and tell me what they ate. And 100% of the time, they would have some story, and it would be like, I grew up in New Zealand on a farm, and all I ate until I was 25 was fresh farm food. Or this one guy I remember, he's like, I don't know. I eat whatever my wife cooks. I've been married to this Japanese woman from Okinawa, and he was a white guy from America. He'd been eating really healthy organic Japanese food for like 30 years. So when people have long, thousands and thousands of meals where they've had polyphenols and fiber just over and over and over, this is going to be perfect. Okay. So if you see this off, then you need to start with polyphenols and fiber and probiotics. And then you start thinking, I wonder if they're stage 2. So you're going to look at the organ markers down here. And they call them intestinal health markers. So steatocrit is a marker for gallbladder function. Elastase is a marker for pancreatic function. And then there's all these markers for immune and inflammatory reactions, secretory IgA, eosinophil activation protein, calprotectin is an inflammatory marker. Okay, so these will let you know if there's a problem with the organs, pancreas, gallbladder, or intestinal tract. Let's see, on this person, they have low SIG-A and high calprotectin. So low SIG-A means low immune function in the gut, and high calprotectin means high inflammation. So they're stage 2. They got the gut intestinal tract problem. So GI Revive would be perfect. 1 or 2 scoops twice a day. Get the SIG-A up to strengthen their immune response. So they get their soldiers back out there in the fight, right? And get the calprotectin down so there's less inflammation, less tissue damage. So stage 2 on that section. And then stage 3 is easy. You just, wherever it says infection or parasites or whatever, so you just scan through the whole test and you'll see bacterial pathogens, parasitic pathogens, those are pathogens. H. pylori, as you all know, is a pathogen. Down here, dysbiotic bacteria, you can see opportunistic overgrowth. These are, I don't know if you want to call them pathogens, but it's dysbiosis. These are dysbiosis markers. So that's something that we'd want to eliminate. Yeast markers, you'd want to eliminate the yeast if it was present. And then there's another section on parasites and worms. So those would be all the stage 3 findings. I think in this case, they had C. diff, you'd want to treat that. H. pylori, you want to treat that. And this is pretty common. You see 2 or 3 infections. And some candida overgrowth. So C. diff, candida overgrowth, and H. pylori. You have 3 different pathogens to treat. That would be in stage 3. Okay. All right, we got a few more minutes here. I just want to show you one more lab. So this is a similar kind of test, different company. This is Genova Diagnostics, and they're very famous for their GI effects test. GI effects. And I still work really. I worked for maybe 10 or 12 years with the scientist that developed this test originally. He's a good friend of mine, Dr. Richard Lord. And we're going to do this in order, okay? So first of all, we're going to look for the microbiome. And this is kind of easy because it says right there, need for microbiome support. Okay, so that's almost kind of like cheating. You don't have to really know anything. You just look at that. And if that's a 10, you know there's a problem, okay? And then where it says need for digestive support, that would be a stage 2. And we'll go into the detail in a minute. And then pathogens are over here with infection. Okay. So I'll show you now that, obviously they have this whole detailed report here I can show you. And let's see, we want to do the microbiome part first, right? So we'll go to that page. So here, gastrointestinal microbiome by PCR. So PCR became famous during COVID, right? Because they started to use that PCR testing quite a bit. Polymerase chain reaction. So they take the stool sample and they amplify the DNA of these samples and in this kind of fancy machine. I don't really know how they work. I've seen them. They're expensive. They're not as big as you would think. They're like the size of your desk or something. And somehow that magically amplifies the DNA. So if you have the DNA of any of these organisms present, they can measure it quantitatively, which is kind of amazing. And PCR for the measurement of gut bacteria was a huge breakthrough because prior to that, what did we do? We did culture. So they would take a stool sample and grow it out in the lab, but that's an oxygen-rich environment. And remember, we just said these are all anaerobes. These are all organisms that live in a no oxygen environment. So who knows what happens if you take a stool sample and you culture it in the lab? It's not going to be really reflecting what's happening inside that person's body at all. It's what's happening inside the lab, So culture was the best that we had until DNA testing came along. But now with PCR, they're taking a stool sample and they're not looking for the live organism. They're looking for a fraction of the DNA of the organism, and then they're doing a quantitative test on the amount of it present, which is going to directly reflect the amount that is in that person's gut in an anaerobic environment, because oxygen is taken out of the picture here. So, I mean, it's a pretty big breakthrough, to be honest. I think PCR, it's probably as important for gut testing as the discovery of the microscope was, honestly, because now we're just freed up from culture. We're freed up from an O&P where a human being is looking under a microscope. Now it's all DNA based. It's a pretty big deal. And so these are very, very accurate tests, which is nice. So now this again, this whole page here, remember on the GI map, it was maybe 10 or 12 markers. This particular lab does 24 commensal bacteria. So these are all the good guys. And I'll point out some of the same ones on here. You can see here's our lactobacillus. That's the one that you see in supplements all the time, or when you drink milk, you get that one, right? Lactose. Here's our F. prausnitzii, Faecalibacterium prausnitzii. That's one that's related to long COVID. Here's our D. piger. Here's our Methanobrevis smithi. Here's our Akkermansia. So again, oops, sorry, I hit the wrong button there. This one is going to be 24 commensal markers, but don't worry, you don't really have to interpret it directly because they have a little graphic here where it says commensal microbiome balance. You see that? And they'll just put that patient, I mean, basically if they're in red, it's bad. If yellow, it's not good, and green is great. This particular one is really good, okay? So they'll just put a little circle where they gauge the person. They have a computer algorithm that runs all 24 of those markers through and kind of analyzes it against a database of like 40,000 tests, and it spits out, is this a good commensal bacteria balance or not, okay? So that's how this lab company assesses the microbiome. And then for organ function, you go right here and you'll see again, it says digestion and absorption. So there's our pancreatic elastase. Is the pancreas working or not? Fecal fat, obviously that's gallbladder. Total products of protein breakdown, that's going to be your stomach acid. Down here, you can see the inflammatory markers for the intestinal tract, like similar, calprotectin, eosinophil protein X, it's the exact same markers, fecal secretory IgA. So these are the immune and inflammatory markers. If they're out of range, then you know there's a organ problem, right, with the organ itself. And then down here are our, I forgot to mention this earlier. These are our short chain fatty acids here. So this is actually microbiome indicators. They actually are measuring butyrate, acetate, propionate. So again, if these are low, then the microbiome's in trouble, right? Because the good gut bacteria are making the short chain fatty acids. The GI map doesn't measure butyrate, but this company does. So there's trade-offs. They're both really good tests, though. I use them both in my practice. So anyways, that's a stage 1 marker, really the gut microbiome there. But the rest of these here, digestion and absorption, these are all looking at organ function: stomach, pancreas, gallbladder, intestine. And then again, the pathogens are easy. I mean, first of all, they tell you right here, is there an infection? If there's a 10 there, they got an infection. But you can go hunt it down. You just kind of search through these pages here and you'll see they mark it pretty clearly. Here's our culture. They still do the culture. It's old fashioned. It's really out of date, to be honest, but they still run it because they have the technology. Um, but obviously the PCR is just better. And then here's the parasitology. So these are pathogens, roundworm, tapeworm, flukes, protozoa. Okay, this one has Giardia, obviously a pathogen present there. And then this is O&P. So this is a human being looking at a microscope to find something. So they still do O&P at this lab. But then they also do, you'll see PCR for parasitology. So they do both. They do an O&P, human being looking under a microscope, and they do the PCR. And so again, they found Giardia on the O&P, and they have Giardia here also detected on the DNA test or PCR test. So pretty easy to find the pathogens on this lab. They just list them out on those pages there. So that again would be a stage 1, the microbiome markers, which would be the commensal bacteria plus the butyrate. The stage 2s would be those stool chemistries I showed, looking at stomach, pancreas, gallbladder, intestinal tract. And then the stage 3 would be pathogens. Now, what does this person need? If we can just probably do it from the summary page. So stage 1 is the microbiome. Oh, and now this is confusing. This is a bad example because remember the microbiome itself was in good shape. So the summary page is misleading here, where it says need for microbiome support. This person's microbiome is in pretty good shape, but they have an overgrowth of bacteria and yeast. So they need the pathogen treatment more so than anything. Their gallbladder's not working that great, okay? And they have an immune response problem in their gut too. But when the main thing that's happening for this person, and probably the most important thing that you have to treat is the Giardia. Okay, so with someone like this, if they have a full-blown pathogen problem like Giardia or E. histo or Dientamoeba fragilis or Cryptosporidium, usually we recommend that you treat either with antibiotics or with the herbal programs. It just depends. We have a lot of cases where doctors end up using antibiotics just because it's faster. Depends on how severe the infection is. So it's always kind of a judgment call. If you want to use the herbal antimicrobials, or if you want to go after the infection with the medication, kind of have to decide between those two options. And it's sort of on a patient by patient case basis, I think, for the most part. All right, let's see. I'm going to wrap it up. We're right at the hour now. Just reminding everybody, we have a ton of these boot camps coming up. If you're interested, you can jump into any of them and you'll get a discount code too. And we do have one on the GI testing. It started just like a week ago. You could probably still get into that one. And I think we're going to do another GI one in November. So if you just look at the Kalish Institute website, you'll see all the classes listed out there and you can pick the one that makes sense for you, And the boot camps are short. Most of them are a month or 6 weeks and just kind of introduce you to the idea of testing. And then, as I mentioned earlier, I don't know, about 6 months ago, we started to work with some of these labs to make sure you guys can get these test kits. And I think that's been worked out now. So you can start to run labs and get into this functional medicine stuff from Costa Rica, which is exciting. Yeah, any questions for me, Sylvia, or anything I should follow up with?
So far, well, I haven't posted in the chat if people want to if they have some questions, but I thought you were gonna do some more examples. Did I misunderstand?
Oh, I can if you want. You want me to look at some more labs?
Sure. Let me just put it out there.
Yeah.
Si alguien tiene preguntas, si quisiera hacer alguna pregunta, pues sería ideal en este momento. Lo pueden poner a través del chat. See something comes in. Oh, perhaps let's do another example. There's if it's okay to do another example, that would be great. And I have a few
Okay.
questions. I was just waiting to see if anyone from the public had questions, but
Okay.
otherwise I have.
All right. Let's look at one more example, then you can start to ask me some questions. So now we kind of getting how this goes, right? So we want to think, we're looking at a new case here. And what's interesting, it doesn't matter what the symptoms are. This could be a fertility case, it could be an autoimmune case, it could be someone that is worried about getting diabetes. It could be someone that's just tired all the time. It could be someone with chronic GI problems. It really doesn't matter. So the analysis and treatment of the gut problems is pretty much independent of their symptomatic expression, which is another counterintuitive part of functional medicine. But we really are just testing and treating organ dysfunction independent of what the person is complaining about. And what ends up happening is that if you get the gut working and the hormone systems working and detox pathways working, then sort of magically all these different health problems start to clear up. So it's a systems-based approach, not a symptomatic-based approach. And we're trying to reach the underlying cause of the problem and then treat that, which is a radical concept. You mentioned in my bio that I worked with the Mayo Clinic, and about 15 years ago, the woman that was in charge of the Mayo Clinic's internal medicine department took my training program. There's like over 100 physicians. It's arguably the most important internal medicine department, at least in the United States. The Americans would say in the world. I'm sure the French would argue with that. The Germans would argue, but a pretty important group of doctors. And she's the one in charge of them, okay? And so we are doing the exit interview. At the end of my class, I just like to talk to the practitioners and, say, how was it? What'd you learn? What could we do better? And the one comment she had that I still remember is that she said, well, it was such an enlightening experience. I don't think I'm going to be able to use this in my job, but I'd really never considered that we should focus on finding the underlying cause of problems. And so this is a person at one of the most elite academic research institutions in the world. And it wasn't even on her conceptual framework to consider that the underlying cause of a problem should be thoroughly investigated. And it just shows that at least in the United States, the way that the conventional doctors are thinking is on this whole other track. And and I'm not saying it's bad or worse or better. If I had a big health problem, I'd be at the Mayo Clinic tomorrow. I'm not against this. But for chronic illness problems and for lifestyle related stuff and for longevity, you really do need to singularly focus, just solely focus on the underlying cause of the problem and almost ignore symptoms completely. And it's hard to do that because the patient wants to drag you into the symptomatic treatment, and it really doesn't work from a systems perspective to operate that way. So anyways, here's another lab. And again, I'm not going through cases and saying what's wrong with the person, because it doesn't really matter. But we just want to analyze these. So first of all, we want to look for the microbiome related problems. And the easiest thing really, honestly, is you just look at the chart thing here. Oh, here they are. So this person's kind of in the red zone, so that's not so good. So that means there's a problem with the commensal bacteria. So then we can kind of scoot over to that page and look at it and see if you can see anything. It's kind of hard. Oh yeah, you can see. So DL means underneath detected limit. So there's a bunch of these that are low. Let's see, 1, 2, 3, 4, 5, 6. Maybe 6 of these markers are underneath the detected limit. And so that's probably part of what happened. I don't see any that are super high, but there's a bunch that are low. Okay, so that kind of gave the person a bad score. And then we want to look for organ function. So the pancreas is working okay. Stomach, gallbladder. Oh, the fecal fat's a little high. So there's a little too much fat in the stool, so maybe the bile is not being produced quite right. But in general, the inflammatory markers are okay. But then when we go down here to what we've talked a lot about, the short chain fatty acids are extremely low. So remember, these are fats that are made from fiber by the gut bacteria. How they do that? It's a miracle. They take fiber and they turn it into fat. And then we use that fat as an energy source and for a whole bunch of other things. So if butyrate is low, or in this case, it's not butyrate, it's acetate. If the short chain fatty acids are low, and again, there's three, butyrate, acetate, propionate. If one of the short chain fatty acids is low, then you've got a problem with the commensal bacteria. And the solution, we kind of obvious, is fiber, right? You can give fiber as a supplement, and you can have people eat high fiber foods. So that would be the microbiome for this patient. And then we want to look at the GI organs. We already did. There wasn't too much going on there. And then we want to screen for pathogens. So for that, you gotta kind of scroll through the whole thing here. Well, we could cheat and go up to the home page, the front page here, and see there is something going on. Under infection, you can see there's some markers there. So we want to hunt that down and see exactly what it was. And again, the culture, you know, it's kind of a little old-fashioned. Kind of probably skip that, to be honest. But here we go, parasitology. Oh, blastocystis hominis. Okay, so that's a nasty little bug. It can get into joint capsules and cause joint pain. It causes IBS, IBD type problems. It's a really nasty little infection. It's very easy to treat with herbs. So blasto, I haven't really seen doctors treat it with antibiotics ever. So you almost always treat blastocystis with something like the GI microbex. That would be the effective treatment for blasto. Giving 1-3 times a day. If that's not strong enough, you could bring it up to 2-3 times a day. But be a little careful. That's a pretty strong product. But that'll get rid of blasto. It takes about 60 days. So if you have a patient with blasto, 60 days on the GI microbex at 2 with each meal would probably knock it out. And then again, so the OMP is a human being looking under a microscope. The PCR is the DNA, and they found the blasto on the DNA marker as well. And they don't always correlate. I mean, they should theoretically, but depending on what samples were sent and how it all goes down, sometimes they'll find it with one technique and not the other, which is a little confusing. But so then this patient, if you go back up to the summary page, they have low short chain fatty acids. So we want to use the fiber. Their microbiome is in not good shape, so you want to use probiotics. The organs were decent. I don't think you need to do like the GI revive with this person, but you definitely would want to kill the blasto. So this person would be like a stage 1 with the probiotics. You could skip to stage 2 probably because they did not have a lot of tissue damage and inflammation, but you definitely want to do the stage 3 with the GI microbex. So it could be pretty easy. I'd probably do 2 months of the GI microbex at 2 with each meal, then stop that completely, then do the probiotics, because usually you want to do the probiotics at the end of the program once you've done the killing to re-inoculate and put all the good bacteria back in the gut. And then do that for probably 2 months and then stop and then retest. And you should see with most of these cases, within the first 3 or 4 weeks, people starting to feel better. And you never know what it's going to be. It could be that their back pain is better. It could be that their, reflux is better. It could be that their sleep is better. I can't tell you how many patients I've had where the main thing that got better with the GI program was the quality of their sleep. It's just incredible, So you never know what symptoms are going to clear up. And I'm usually trying to be kind of neutral with patients and not tell them what I think is going to happen because I'm usually wrong, and just say, okay, let's see how it goes, and check in with them like once a month and just make a good record, good documentation of what happens, because it's just incredible the things that change when you do these GI programs.
Well, thank you so much. That was amazing. I
Yeah.
think we could abuse time and just take an extra hour and it would just go flying because this is really, really interesting. So we have a few questions. One is, what is the best time to take a probiotic and should it be on an empty stomach?
Yeah, so the theory there, this is more naturopathic theory, is that if you take the probiotic with food, it obviously gets mixed in with your food and maybe is going to hit your small intestine a little bit more. If you take it on an empty stomach, not as much food present, it's going to not really, it's going to travel a little bit further down the intestinal tract. I don't really know if that's true or not, but basically the bottom line is you can use it either way, either with meals or without meals. The main thing is that you take it away in time from any kind of antimicrobials. And sometimes patients notice that it has a much more beneficial effect in either with food or without food. So you can also have them try it both ways and see if one way is, better for that individual or not. In terms of people actually remembering to do it, I think with meals it's easier to remember, but it's not necessarily always done that way.
Okay. The second question is with and I'm sorry if I'm mispronouncing this, archaeas. When you have clinical presentations of archaeas in the small intestine, do you recommend the use of antibiotics or just to work on the probiotics?
Wait, was archaea? Do they mean the one that I was talking about, or?
Archaeas, I think when you were talking of this other organism that
Oh yeah,
is,
yeah. No, that one, that's a commensal. That's a
that's
good guy.
commensal. Okay.
I mean, I guess it can overgrow.
Hmm.
So I guess that's an important point. So the commensals can overgrow. And then the question is, what do you do about it? Are you going to kill a commensal because there's too much of it?
Hmm.
I don't know. It's a question. It's a question that's kind of difficult to answer, to be honest. So I think the sophisticated approach is to say, well, we're not going to kill it because it's a good guy, but we know that these good guys are dependent on one another. So if one of them is overgrowing, like the archaea one, it's dependent on other organisms. If we balance out the other organisms, then the one that's overgrowing will sort of take care of itself. So rather than having to target the good organisms, if you simply do that balancing act that I was trying to describe, the fiber consuming ones, the hydrogen producing ones, the hydrogen consuming ones, if you get those all in alignment, then they sort of sort themselves out without you having to target individual commensals.
Okay, so your recommendation would be to start up with the fiber and the polyphenols and perhaps a probiotic and let it sort itself out and then
Yeah.
repeat the test. All right.
Yep. Yep.
And then another question here is how to correlate the GI map results and the needs of probiotics if you have a product with a determined amount and variety of the strains.
Yeah, I don't think you can really do that. People are trying. They're trying to like develop probiotic formulas that like are just for Akkermansia boosting, or I don't know how well that's going to go. There are some that they're developing now to boost Faecalibacterium prausnitzii, but I don't think we know. I think it's how could I say it? Is that reductionism when you get too specific like that? It's a little reductionist. It's a little bit like it's a little. I don't know that that's going to work in the longer run, because there's a bigger picture at play than these individual organisms. There's the food supply that the person's consuming. There's the pathogens. So I think ultimately most of the corrections for the microbiome are going to come from getting rid of all the infections for sure. You have to kill everything, getting the organs to work pretty well, and then just keeping that person's diet consistent for 6 months, a year, 2 years. And I don't know. I think what I see now at the conferences I go to is people are getting a little overly focused on individual organisms and just trying to fix them. And in the past in medicine, that hasn't gone so well. You know what I mean? When we get kind of obsessively focused on one little problem and we're missing the bigger picture. Um, it would be like, if someone had a problem with their cardiovascular system and you just put them on a statin, but you didn't talk to them about their diet and exercise, or they're still smoking cigarettes or something. I think there's a bigger picture that we should be working with, and you don't have to be that super targeted. But there's some exceptions to that, though. I can mention the exceptions if you want. So the exceptions are, because this actually does work. If you want to get and this has been around for a long time, if they have low lactobacillus, you can give a lactobacillus related probiotic. And if they have low bifidobacter, you could give a bifidobacter. And then I can show you, let me see, let me try to pull this up really quick. It's not one of the slides that I was showing tonight, but I have an image of it that may answer this question too. Let's see. because you guys have cameras, you just take a quick picture of this. Let's see. Oh yeah, here it is. I got it. All right. Let me show this on the screen here. So here's, and again, I'm not a really strong advocate of this list, but I do have it. I use it sometimes. So here's specific targets. M. smithii low, you can do these foods or this supplement. Deep hydra low, you can do this or that. Akkermansia low. They also use berberine for akkermansia. Berberine's been shown to bring up the akkermansia. So you can take a snapshot of this, and this is one kind of general guide for certain specific organisms. Like for deep hydra, you can use sulfur compounds like chondroitin and sulfate because it's a sulfur-consuming bacteria. It actually consumes sulfur, which is a little strange, but that's kind of its food supply. So this is something you can work off too. I think, yeah, here, I didn't show these very in detail, but here are some of the key markers too. You can take a snapshot of that maybe. These are ones that help with hydrogen removal to a certain extent, hydrogen consuming bacteria, the M. smithii and the deep hydra. Akkermansia is a little different. And then there's another grouping here, this one. These are the main hydrogen producing bacteria. They do other stuff too, but they're the major producers just by volume, than the sheer numbers of them. High abundance, meaning there's a lot of them hydrogen producing. And I have one more list here. Let's see, don't I? Yeah, here. And then these are the high abundance commensals that are converting the fiber to sugars and the short chain fatty acids. Also, these are present in large amounts.
You had mentioned that, I'm sorry if I don't pronounce this correctly, Faecalibacterium prausnitzii is related to long COVID, correct?
Yeah, there's a bunch
And
of research showing that. Yeah, long COVID patients tend to have low Faecalibacterium prausnitzii.
and this is, I'm sorry, this is a short chain fatty acid commensal, correct? Not the hydrogen one, the
Yes,
Faecalibacterium.
yes,
Okay.
yes. And that means if I don't know if you guys have it available in Costa Rica, but you can use butyrate as a supplement. Designs for Health has a product called Tributyrin, which is pretty amazing, but it's actually butyrate in a pill. If you guys can get your hands on that, it's one of the more powerful supplements that we have here in the U.S. And that would be the treatment of choice with low F. We can just call it F prausnitzii, low F prausnitzii. Butyrate. If you guys can get your hands on that, the Designs for Health version of that is actually one of the better ones available.
Okay, and then coming back to this whole GI map question with the Akkermansia, which you said also is incredibly important, correct?
Mm-hmm.
This would get balanced just by balancing with the probiotic and, for example, the GI revive, because we're just doing that whole chain of the short chain fatty acid producing bacteria with the hydrogen with that. So
Yeah.
in essence, we have like all this information from the GI tests that are super specific, but the treatment in itself with the probiotics are certain strains that balance out the rest of the strains. That's what we're understanding, right? So we don't give specific targets of bacteria, but rather go to the base of the problem and start with that diagram that you gave us.
Yeah, I mean, there's a new company that just came out with an Akkermansia specific probiotic, and I'm sure it'll help some people, but that's getting more like a targeted drug approach versus a more holistic approach, and the thing is that, I mean, I'm sure that supplement works really well, but that's not really the point. You know what I mean? So then like, if you're going to do that, just give them a drug, this, the thing is that we're trying to get people to eat well, and we're trying to get people to, chew their food and eat their beans and blueberries and stuff. And so if you get too targeted, you're kind of drifting away from the main concept, which is that we're trying to change the lifestyle to make this whole larger correction. So let's say you do buy the Akkermansia product and you do fix the Akkermansia. What about the other couple hundred organisms, I mean, is that really going to help them? Probably a little bit, but not a lot. Not as much as it would if you just got polyphenols and fiber and probiotics and that kind of stuff going. So I guess that's the thing. You want to think more systems wide. Or what did my friend Bill Queel said the other day? The body is a system of systems, and so you want to think more digestive system wide and not overly targeted on one little thing.
Perfect. We have one last question, then we'll let you go. I'm so sorry. I hadn't looked at, I got a bit overexcited. It's almost 8:30. So how much time do you recommend to take probiotics? That's the last question we have.
Well, I mean, you can take them every day as like a maintenance product. I think for the most part with what we're talking about tonight, it's more as a treatment based on the labs. So the treatment time based on the labs would be probably 2 to 6 months. But they can also be just one a day as part of a regular healthy program for people too. But today's context is more like treatment for people that are having problems. So probably like 2 to 6 months. And the other thing with probiotics is in general, you don't want to use the exact same probiotic year after year. So after a 2 to 6 month range of whatever, you're using from whatever company, you should switch to a different formula because the microbiome needs to be diverse, right? You don't want to just keep supplying the exact same probiotic year after year after year. You want some diversity there. And that's another way some companies get around that problem is they'll just have a single product that has a whole bunch of different organisms in it. So that's another workaround. But if you're giving a single, like a lactobacillus probiotic or something, don't use that one strain for more than maybe 2 to 6 months, or just go to a multi-strain probiotic. That's another way you can deal with that problem.
Great. Well, thank you so much, Dr. Kalish. This has been an amazing talk. Again, the omega-3 was also fantastic. And
thank you.
Hopefully we'll be able to have you at some point in the future and maybe come to Costa Rica as well.
Oh yeah, you're at the top of my travel list. Costa Rica's #1 next place, so we're going. So we'll be in touch, okay?
Oh, that's great. Well, we'll be very happy to have you here. So please do let us know. And thank you so much again for this wonderful talk.
Thanks. Good night now.
Good night. Buenas noches a todos.
Bye-bye.
Muchas gracias.